Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, we have a design problem and I will show you two approaches to solve this problem. And I will show exactly how we can improve the time complexity. Although theoretically both of the methods have practically the same time complexity, but the percentage bits will be different in each of the method because of the optimization factors. So how we will do that, how we will explain it, how we will ensure it that it increases the time complexity. So we will see in detail. So let's see the problem. You are asked to design a data structure which will handle two kinds of operations. So you will have only two arrays, nums1 and nums2. Your data structure should have two arrays, nums1 and nums2, and uh, in one kind of operation is add, in which you will add a positive integer to the element at a particular index only, and another operation is count. You will count the number of pairs I comma j such that nums of I, array of I, and array of 2 of j, that equals a particular value. That should give you a particular value, and you should do it optimally. Optimally in the sense, the constraints are given. Nums1 dot length is 1000 and nums2 dot length is 105. So if you try to see how can you approach these problems, uh, first of all, you need to initialize the vectors, right? Num1 and num2. But first, you think that what will be the time complexity that I will need to write under each function. Okay. So this is the first thing which you need to analyze. What will you do? How will you analyze it? You will see these two information and how many calls are made. These informations will be helpful. Okay. So you see, 1000 calls are made to add and count. Okay. And add, what you are doing in add, in a vector of length 1e5, you are changing the index. So you see, you are handling a vector of length 1e5 and 1000 calls are made. So you cannot do anything which is even linear time. Okay, so it will result in 1e8. So the operations which you should do here is either O of one time or O of log n time. Okay. Okay, the thing operations which you should do here, which is either O of n or O of log n. Now, the count function, you see, count function is nothing but counts the number of pairs such that nums I and nums j. That sum is total, right? That sum is total. This is also counted 1000 times. Okay, so you cannot do anything. First of all, you cannot do anything which is n m into n. Let's say this nums1 dot length. Let's say this n1 l1 is, let's say, length 1, that is the nums1 dot length is, let's say, m, and nums2 dot length is something like n. You cannot do what you cannot do. Time complexity of O of m into n, this will not do. Okay, so this will be wrong. This will be wrong. If you try to do something like time complexity of, let's say, O of n, then also it will be wrong. Then also it will be wrong because you see, O of n is nothing but 1e5, and you have to make 1000 calls even to this. Okay, 1000 calls. So that will be 1e8, and you know 1e8 does not work. It will give a TLE. So these two methods give a TLE. Okay, what can you do here? You can do something like O of m, because O of m is what? 1000, right? M value is 1000. So you see, I'm just also writing this. This is nothing but 1000, and n is nothing but 1e5. So since these are true, O of m you can do, or something like, yeah. So this O of m only you can do, or even less if you can do. That's better. That's better. Okay. So I hope you understood this. I hope you easily understood what I mean to say. How will you analyze such problems? So first you need to think what will be the time complexity of the code that I will write under each function. Add and count, it is okay, but this, what will be the time complexity of this? We can easily do O of m n, okay, or O of m, or like O of m plus n also, okay. It's 1e5 and it will be called only once. This will not be called 1000 times. This will be called only once. So you can do O of n or O of m. Okay, nothing. A or m plus n, anything you can do. Okay, so I hope you understood this. The first step is completed, that we need to analyze what is the I mean, what is the time complexity that we will write? What that will write. Now, in a design problem, in a data structure, you do have some private variables. That's how you encapsulate something, right? If you already know, oops, okay, if you already know C++, object-oriented programming, then you will realize that you have some private variables which you need to initialize. So, let you see these nums1 and nums2 must be those vectors. Okay, so you have two vectors. First of all, you should have two vectors. Okay. Uh, do you think we need anything else? Do you think we need anything else? Okay. So, let's now see how to approach the problem. Then only we will be able to move forward in understanding how much, I mean, how exactly we will solve. So we can do something simple. First of all, is initialize this vector 1 and vector 2. So after this initialization is done, let's see how to solve the problem. Okay, let's see how to solve the problem. How we will do this index addition and how we will do this count. So first try to think. So first of all, this index addition, I think it is very simple, right? It's very simple. You have a vector, you have some vector, you have some elements in those vectors. And suppose you want to add an x to this number at index I. So what you will be given in the function, you will be given index as well as value. So what you can do, you just go to the vector, you just have this index. You just take the index and increment this x. Okay, you just increment this x. So you have done it in O of 1, which is already satisfying this. And that's okay. That's okay. That's done completely. Now what about count? Now what about count? If you try to see, it will be interesting. First, and a very crude way is to do brute force. Okay, so how can you brute force it? Okay, so I hope you easily understand that. First of all, you can do something like iterate through this I from this vector 1. So I'm doing nums1 and nums2. Okay, vector 1 and vector 2. So whatever, this you iterate through this first vector, then you iterate through the second vector. Okay, I hope you understand this, right? This is a very intuitive approach which should definitely come to your mind. If nothing else is coming, this should definitely come, whatever be the case. Okay, so you see, you can do what you can do. You can keep an answer value, and if you just check that if the criteria is getting valid, criteria, I mean this nums of 2 of I plus this nums of 1 of whatever this, not 2 of I, it will be 1 of I. Okay, 1 of I plus this nums of 2 of j. If it is something like equal to the total value which is given to you, then you just increment your answer because you got a single pair and you just return answer. So you can see that this is nothing but O of m into n time complexity. And in our initial analysis, we have already told that this is not allowed. This is not allowed. This is something which is not allowed. We have to find something which is in O of m. Okay. Okay. So let's first of all, I will take an example. Okay. So first we take first vector, which is something like, so let's say total is 7. Okay. We have made a call of total to be 7. And I have some things like this. 3 is present 2 times, and let's say I have a 4. Okay, this I have vector in this, and I have something like 5 here, 5 here, and let's say I have 4 only 2 times, and I have 6 one time. Okay, so you see, we need to see that in how many ways can it make 7. So initially what we did is we iterated through this vector 1 and vector 2 and just check the numbers simply. What can you do is that you have a long vector and a short vector. Okay, so this is long here, but actually in the problem, if you see, one is of length 1000. So this vector can be at max length 1000. So this is the vector which is the short one, and this is the vector which is the long one. Okay, so what can you do? You are allowed to iterate in this vector. You see, oh, this is m, this is n. I have already analyzed that O of m is allowed. So you are allowed to iterate in this vector. So let's say you want to find a sum of total. Okay, which should be, so you iterate through every element of this. Let's say you have an element of this and find what is the frequency of the element which is total minus x. Okay, total minus x. So I hope you understand this. If an element x is there and y is there, and x plus y needs to be total, okay, and you are iterating through all the elements of x, and you just find that how many elements total minus y is present in this vector. Okay, how many elements total minus y is present in this vector. In this way you can just add those elements, and you can just make up your total answer. So what can you do for frequency? As I told you about frequency, so you easily understand that you need a map for the frequencies. Okay, so let's say you have a frequency map, let's call it m2. Okay, what will it have? First frequency is 5. Okay, 5 has a frequency of 2. Okay, this 4 has a frequency of 2. This 6 has a frequency of 1. Okay, so your map has these three elements, first of all. Okay, now what you do, as I told you, you are allowed to iterate in vector 1, the shorter vector. So as you are iterating through this, you got the first element as 1. Now you check, total is 7 here. So 7 minus 1, 6. Is 6 present? What is the frequency of 6? So your answer initially, which was initialized to 0, it becomes 1 because the frequencies of 6 is 1. 6 plus 1 is 7 also, right? Then again, this for this one, it will go and search for 6. It will if answer will increment to 2 because the frequency is 1. Okay, now you see you get 4, 2. Now for each of the 2 you have two fives. Okay, so what can you do? Every time if you are in this 2, it will, I mean, it will check that 7 minus 2 is nothing but 5. It will go and search for 5 in this vector, and it will find 2 times. So every time it will get plus equal to 2. Every time answer will be plus equal to 2. So 2 will get to 4, it will get to 6, it will get to 8. Okay, and when you get to 3, you see 3 has 2 occurrences and 4. So you see the total will be 12. You see the total will be 12. I hope you understand this, right? 7 minus 3 is 4, and you search for 4 in this map. You search the frequency of 4, which is 2, and you add that frequency to your answer. So that's simple, right? That's how you can count. You just keep adding all the frequencies to that answer. So now let's try to code it out and check how can we optimize these solutions. How can we optimize them more and more? So as I told you, we need a map. But how many maps we need? We need a single map, M2. So we store the frequency in that map. So let me have a map. Okay, I will store frequency in that map. Okay, so I will iterate through all the elements in vector 2, and I will have a map which will get implemented. Okay, so stores the frequency of M2, stores frequency of nums2 only. Okay, why you already have understood. And this is very simple. This is very simple. We can just add this num vector in the vector 2. I will go to that particular index, and I will just add the particular value. I will just add this particular value. But do you think this is sufficient for this? Do you think this is sufficient? What you are doing is that you are also maintaining a map, right? If let's say in the vector 2, let's say I am adding some, let's say 10 to this. So this 4 becomes 14 now. Okay, so how will we check that in the map? So 4 was the old value, 14 is the new value. So what you can do, you can subtract the old value. So what you can do, you can subtract the old value from the map, decrement the frequency, and you can increment a new value in the map. So what was the old value? You can just check that your map now no longer contains this new value, the old value. Okay, your map no longer contains the old value, so you just decrement it. Okay, so what I am doing here is decrementing frequency of a old value. I guess you understand that this something we are doing, we are adding each element, right? Add gives to the add a positive integer to the element at a given index. So we are adding some value, old value plus current value gives you a new value. Okay. So you are adding something. So you need to subtract this from the map also, and you just increment the new value. What will be the new value now? It has already incremented. Okay. So after this is nothing but incrementation. What we did here, incrementing the frequency of the new value. What we did is very simple. We just incremented the frequency of the new value. I hope you understood this now easily. So now we do what is simple. We iterate in O of m time. So I will just go through all the elements of vector 2 dot size, vector 1 dot size. Okay. I will just, because that is the smaller vector, as I told you, I iterate to the smaller vector, and the bigger vector, I have already kept it in a map. I've already kept it in a map. Now let's keep the map as something like map of 2, because it will show that the vector 2 is getting stored in this map. And uh, what will what we can do is that we can just add this map 2 of uh, I will go in this particular value, and I will check whether total, this is the total, right? This is the total, and this total minus this thing is present in the map or not. Okay. Whatever be the frequency of that, I will just add that frequency to my answer. Okay. I am just adding that frequency to my answer. And if something is not present, you already know that we get a frequency of 0 in the map. So that will be easy. So you just keep adding the frequencies. Okay. Keep adding frequencies. I guess this should work. I guess this should work. But do you think it will be very optimal? Let's try to see if it works. Let's try to submit it and check now. So see, we have a 12% and 8% bit. So let's try to improve it. Okay, let's try to improve it. What we can see every time we are going and checking whether this is present, you just add this value. So if not, the map initializes a new memory to this, and initializes the value of 0 to this and adds this value of 0 if it is not present. But in a long vector, it might happen many times that it is not present. So what you can do in O of one time, you can just check. You just check in O of one time that if map2 dot count, okay, this value, you call this remaining, okay? You just search for the remaining value, right? Uh, let's call it remaining so that we can use it again and again. And in this remaining, you just count if this remaining has a frequency of greater than 0, then only add the frequency, okay? If this, then only it makes sense to add the frequency. So if you try to do this and submit, you'll see you will get a very good runtime complexity. At least something better, How can you make it more better? You see, O of map works in log n time, right? Map works in log n time. You can do it unordered map, which works in amortized log of 1. Okay, this works in amortized O of 1 amortized. If you don't know what is amortized, you just Google it out. Okay, this is a thing which should be known in the data structures. This map, unordered map, stores in O of 1 amortized. So if you try to submit now, yes, you will get more better time complexity. See, you definitely get more better, but can you do something which is more accurate? Okay. So let's try how we can do it. Let's try how we can improve it more. So you see here, if the repetitions of numbers are there, like 2 is present 3 times, we can optimize it, right? We can optimize it. So what can so now if I try to keep another map, you see the frequency of 1 is 2, frequency of 2 is 3, frequency of 3 is 2, frequency of 4 is 1. And in this map 2, if you try to think, frequency of 5 is 2, 4 is 2, and this 6 is 1. So if you, what can you do here is that for you, since you are iterating through this whole vector, instead of that you iterate through this map. And you see, there for every one you have this 6, right? For every one you have this 6, and for every 2 you have this 5. So instead of iterating through 2 3 times, you see that if you combine this 2 with 5, you get something 7, right? Your total thing was 7. So you can multiply the frequency of 2, the frequency of 2 with frequency of 5. Okay, so you are adding 3 times you are adding 2. So instead you do something like this: 3 into 2, which is 6. Okay, so you add this to your answer. So what you do, you just iterate through the map. So you know, if you don't know how to iterate, okay, so for auto key comma value pairs, you just iterate it through this map 1. And what you can do is simple. You can search for the remaining, which is total minus key. You can search from the remaining, this remaining in map 2, and you multiply it. Okay, you multiply it with something like the key. You multiply it with value. Okay, value. So the frequencies you are just multiplying instead of keeping adding it again and again. So I hope you understood this. You were doing so earlier. What you were doing were something like this: 1 is getting added 2 times. This 2 plus 5 is 7. So this 2 is getting added 3 times. So instead of all these, what you do now is you just multiply the frequencies. Okay, you just multiply the frequencies in this way. The answer will be the same, and you just need to iterate through the map instead of the vector. So you can try to do that. You can definitely try to do that. So for that, you can understand that you need to create another map, and that also you need to store the frequencies. Okay, so frequency of both the map you just take care of. You just take care of both the frequencies. And what you can do now is very simple, is that you just if this count is present, what you do, you just multiply this value remaining. What is the remaining now? You iterate through the, first of all, you iterate through the this key comma value pair, right? This key comma value pair in map 1. So instead of map 1, instead of v1, you iterate through map 1. Instead of v1, iterate through this map 1. Okay, so once you do this, once you do this, the remaining value is nothing but key minus key, total minus key. I hope you can easily visualize this, right? The remaining value is nothing but total minus key. And you see, if map2.count is still greater than 0, what you can do is that you just multiply this value with this map2 of remaining. Okay, so I hope you easily understood this, and you do get how it should increase the time complexity. Now, if I try to submit it, it may not always increase because it's only a small change which we are doing. So let's try to see if it actually gets increased. Not necessarily the space complexity should decrease because I am using another map. So see, we get 92% bits. So the earlier was a little less, I guess, a little less. So whatever be the case, this is not always reliable, not always, but you do understand that method can be the most optimal thing you can ever get. So that's all for this video. This was a medium kind of problem, design problem, and if you already know to some, this should be very easy to you, at least the initial approaches. So yeah, that's all for this video. I hope you will have a nice day ahead. Thank you so much.